Okay, this is the third video that I'm going to do on geometric sequences. I think it's the sixth one I've done while sitting here. So here we go. This one, it says a ball is dropped from the senior bridge 16 feet above the ground. How high will the ball reach on the sixth bounce if it reaches 80% of its height after each bounce? So this is one where drawing the picture is huge. Okay, so it's falling from the senior bridge, and it fell 16 feet. And then it comes up 80% of that. So if I come in here, I'm at 16, and I can multiply that by a point. Okay, hang on, let me do it this way. 16, hit enter, and then I'm multiplying it by 80%. So now on its return trip, it's gone 12.8 feet up. Well, then it gets up there, then it's going to turn around and fall back down also. Then it's going to bounce back up. Can you see that? Okay. It's going to bounce up 80% of that and then fall back down, where these are both 10.24. I don't know if you can read that, but that's what it says. And then it's going to bounce up 80% of that. Oop. I don't know, I just didn't hit enter, sorry. This is 8.192. Okay. And then it's going to fall. So when it says how high will the ball reach on the sixth bounce? Okay, so here's the first bounce. Here's the second, here's the third, here's the fourth. I don't need to draw it all the way out to 6, but I think drawing it and labeling it to this point is huge. So what we can do is we can write two different equations that they're slightly different. They're going to have a lot of the same numbers, but not all. So one thing that we could do is we could do a sequence, and I could call this D1, and this could be D2, and this could be D3, and this could be D4. And that's how much it's going down the first time, down the second time, down the third time. And so on this one, D sub 1 is equal to our, sorry, can you see this? Is equal to our initial amount, our first term. I lied, I want D sub n, I'm so sorry. Our common ratio is 80%, so 0.8 and times n minus 1. Okay, that is what's happening if we just look at the downward motion of the ball. So then we're dropping a ball. And how high will it reach on its sixth bounce? Well, so notice on its first bounce, when I plug in 1, that's how far down it went the first time. So it's never going to bounce up that much. So notice it's going, this amount that it goes up after the first bounce is really what it's going to do down the second time, if that makes sense. So this right here, this how high did it go after the first bounce? That's going to be equal to D2. So in this particular method, how high will the ball reach? Let me read that directions again. How high will the ball reach on the sixth bounce? So it's bounced a sixth time. How high does it go up? Well, that's going to be the amount that it goes up. That's going to be D7 is going to be our answer that we're looking for on that one. The other thing that we can do is that we can call this U1, then call this one U2, and call this one U3, and so forth, where we're talking about this is the amount we go up each time. Okay, so I've got the downward motion and I've got the upward motion. So if I would look at the upward motion, U sub n would be equal to, well, 12.8 times 0.8 to the n. Oh, I lied, n minus 1. Or I could say U sub n is equal to 16 times 0.8 to just the n. I'm sorry, if that's just too complicated and you don't quite, so what it's doing is it's that first downward motion. And so in this case, let's use this equation because that makes a little more sense. So U sub n is, U sub 1 was how high did it go after the first bounce. U sub 2 is how high did it go after the second bounce. U sub 3 is how high did it go after the third bounce. So U sub 6 is going to be how high does it go after the sixth bounce, and that's what we're looking for. So you can either say 16 times 0.8 raised to the, we said we wanted D7, to the 7 minus 1. Or we could say, which means it's going to go up 4 feet after that sixth bounce. Or we could say, I don't know if these numbers are based in real life, but whatever. 0.8 raised, we can use this formula and say that we're looking for the sixth term. And notice that either way we do it, okay, that passing period is over, I guess. It's lunchtime, so here we go. That's why I have all the bells today. Either way you get there, it's going to go back up about a little over 4 feet. So IB likes 2 sig figs. I lied. IB likes 3 sig figs. So it's 4.19 would be your best answer. Good luck, or you could change this. Could you change it to a fraction? No, it doesn't want to do that. Okay, so good luck. Go practice, 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 and we'll keep working on it.